Good morning, seventh grade. I want to go ahead and take this opportunity now we are going to have a test on Thursday, and this test is going to be very similar to the one that you have here on the screen. And hopefully you can see both your test prep worksheet that was due, you were supposed to have completed on Thursday, and you can then also see my screen, which just has a blank sheet of loose leaf. We're going to take this as an opportunity to kind of go through this first page today. So we're going to go through questions 1 through 5 today, and then tomorrow we'll go through the rest of the questions 6 through 9. And we'll make sure that you have a very good understanding of these questions and the way in which they're presented, because your test is going to look very similar to this one, okay? Let's go ahead and let's get started. Again, our Chapter 7 test prep. Again, we're just working on that same assignment that was assigned on Thursday, I believe. You should have already turned it into the Google Classroom. And let's go ahead and let's get busy. All right, so let's get busy with number 1. So it looks like our question for number 1 says, the random numbers below represent 10 trials of a situation. And these are the numbers, guys, that they give us. So there was 10 different trials that were done. And if you remember, this was from our last lesson. This was from that lesson 7-7. The numbers 0 through 7 represent students who watched television last night, and the numbers 8 and 9 represent those that did not. Based on the simulated data, what is the probability that exactly 2 out of a group of 4 randomly selected watch television? So let's simplify this a little bit for us. Okay, so 0 through 7, and I'll label that with a W. Those watch television. Then I'm also going to label 8 through 9 as a did not. So I'll put that as an N. They did not watch television. So in this scenario, I'm wanting exactly 2 out of 4. So I'm wanting exactly 2 W's, and I'm wanting, which would mean I'd have to have exactly 2 N's as well. So we can go through these. So my first combination, it's look like 2, 6, 3, 2. So if I were to go through and label this, well, all of these numbers are between 0 and 7. So this is going to be watch, 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 and watch. That one doesn't work because I want exactly 2 W's and exactly 2 not watched. So that one doesn't work. Let's try the next one. So I've got 1, 3, 6, 5. Again, none of these numbers are greater than 7. So they're all going to be for those who watch television. Move on to the next one. 9, 3, 6, 7. Well, now I've got a 9. 9 is going to stand for not watched. I've got 3, 6, and 7, though. Those all stand for watch television. So I'm not looking real good right now. My next combination, 2, 0, 5, 6. Again, all between 0 and 7. So those are all going to be watched. And guys, this is what I like to do with these problems at the get-go. Go ahead and label them and label what all my numbers stand for. So instead of looking at just these random layouts of numbers, I can actually view, okay, what it means. So if I go through here, I know that this series of numbers means all 4 of the people in that trial watch television. Whereas on this middle one here, I know of the 4 people, 1 of them did not watch television. All right, there's your first row. So that takes care of this section right here. Let's move on to the next one. So I've got 6, 5, 6, 4. Again, all between 0 and 7. I've got 1, 4, 3, 4. All between 0 and 7. I've got 8, 0, 4, 5. Now, 8, that's back into this 8 to 9 category. So that's going to be a not watched, and then 3 watches. I've got 4, 7, 8, 1. So I've got a watch, watch, not watch, and watch. And then my last combination, 8, 6, 8, 1. 8, 6, 8, 1. So that's going to be a no, a watch, a no, and a watch. And again, I'm wanting which of these combinations has exactly 2 W's and exactly 2 not watches. Well, it's not this one. Nope. Nope. That one's only got 1. Nope. 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 Again, only 1. Only 1. And hey, look at my last one here. I've got 2 N's and I've got 2 W's. So I've got one scenario where this one works. So if I write this as a fraction, I can write it as a 1 in the numerator. And then it was out of how many different trials? Well, if you count up all your trials, there was 10 trials. So the answer would be 1/10. So that one's going to be letter A. There you go. All right, let's take a look at number 2. Kind of move right along with these. Number 2, the yearbook club is handing out T-shirts to its members. That was nice of them. There are 5 blue, 7 green, 9 red, and 4 yellow T-shirts in all. Guys, anytime I hear these words in all, I'm going to think, okay, somewhere in this, I'm going to have to add something together. Let's play along. Let's see what happens. If Jacob is handed a T-shirt, what is the probability that the color is red? Okay, so with this one, again, we're thinking probability, so I'm looking at a fraction of some sort. I want my favorable outcome on top. I want my total on the bottom. So there you go. You see that in all? I hadn't even finished the question yet, and I see T-shirts in all. I'm already knowing, okay, I'm going to have to add something together. So if I go through and I add up all my T-shirts, so 5 plus 7 plus 9 plus 4, and it looks like that's all of them. Okay, so if I add those 4 numbers together, guys, use your calculator if you need to. Okay, so I got 5 and 4, that makes 9. 9 plus 9 is 18. 18, you add 7 to it, you're going to get 25. So I've got 25 T-shirts in all. Okay, last step, how many of them are red? So what's the probability that it's a red one? There are 9 red, so it tells me my instructions. There you go. There's your fraction, 9 over 25. And that matches up with, again, letter A. Let's move right along. So let's get on to number 3. So number 3, I've got a spinner. A spinner has 6 equal sized sections numbered 1, 1, 2, 2, 3, and 4. So if you're looking at a visual of this, here's my spinner. Need to move it up on your screen a little bit. Here's my spinner, and we're going to do our best to pretend that Mr. Garrett just drew some equally sized sections here, okay? But if we were to go through and label, we'd have 1, 1, 2, 2, 3, and 4. What is the sample space for the spinner? What is the sample space for the spinner? Remember, sample space. It is all of your possible outcomes. It is all of what can happen. You cannot leave a number out. So if I've got 6 equally sized sections and they give me 6 different numbers here, all 6 of those numbers need to be in your sample space. So my sample space, guys, is going to be every number that's on this spinner. So 1, I see 1 again, I see 2 twice, I see 3, and I also see 4. So that's going to be my sample space. My sample space is every single thing that I could possibly land on. So if we look at our choices, that one lines up with letter D. So hopefully you put letter D for your answers. All right, let's move ahead to number 4. We've got 2 problems left. I broke this up for you guys. That way you weren't sitting here watching a video that would be a half hour, 40 minutes long. Number 4. A game has 15 balls for each of the letters B, I, N, G, and O. That's traditional bingo. The table shows the results of drawing the balls 1,250 times. For which letter is the experimental probability closest to the theoretical probability? Explain. Guys, for this question, number 4, you had to know the difference between experimental probability and theoretical probability. Let's get started with, I'm going to do it theoretical first. Write this down. Mr. Garrett's messing up on his spelling today. All right, I want to look at theoretical first. You've got to know the difference on these two. Theoretical is the probability that we are the most used to. It is just, if I give you the situation, what happens? So, if we played a game of bingo, and we were to play a game of bingo, and again, there's 15 balls for each letter. And I want to know how many times what's the probability of drawing one of the letters, okay? Well, I have what over what? So say I want to find the probability of a B, of grabbing a B out. So if I show for the probability of a B, okay, well, how many B's are there in a game of bingo? Well, it says right here, a game has 15 balls for each of these. So I'm going to have 15 of B. What's my denominator here? It's out of how many? Well, I've got 5 letters, and there's 15 balls for each letter. Well, if you do 5 times 15, or if you're an avid bingo player, you're going to know, guys, there's 75 different bingo or different numbers in bingo. It goes from B1 to 075. So the probability of a B, guys, of pulling a B, is there's 75 different bingo balls, and there's 15 that are B's. So B1, B2, B3, B4, and so on. So this is my theoretical probability. And guys, I really don't need to find theoretical probability for all of these because they're all going to be the same for every single letter. There's 15 for B, 15 for I, 15 for N, 15 for G, and 15 for O, and there's always going to be out of 75. So with theoretical, the last thing I need to do is I need to simplify this down and find the percent. So 15 over 75. They're both divisible by 5. So if I do 15 divided by 5, I get 3. If I do 75 divided by 5, I get 15. We can divide this one a little bit more. So I do 3. I can divide each by 3. So I'm going to be left with 1/5. So you've got a 1 in 5 chance of pulling out a B theoretically. Now, if we turn this into a percentage, I can do 1 divided by 5. That's going to give me 20%. So I'm looking for which of these is the closest to 20%. Now, let's get into experimental. So experimental is, okay, this actually happened. Which percentage is closest? So let's look at the letter B. And this time we're going to have to do all the letters. So the letter B. How many times did they pull the letter B? Well, if I look at my chart, they pulled the letter B 247 times. So I'm going to have 247 divided by, Okay, how many times were balls drawn? They were drawn 1,250. So I'm going to take 247 divided by 1,250. Guys, use your calculator on these. Don't make it harder on you than what it is. Also, do not round on these, because when you find the percentage here, this one comes out to be 19.76%. Kind of funny, because I believe that was our bicentennial. Comes out to 19.76%. That's very close to 20%, but there might be one that's closer based on how the decimal is. So leave it the way it is. Leave it the way you see it. All right, let's move into I. And again, I'm going to do the same thing. It's over 1,250 because the amount of balls that were drawn is different it's the same every single time. Well, now how many times was I drawn? It was drawn 272. Excuse me. And then we do 272 divided by 1,250. Excuse me. All right, this time your percentage comes out to be 21.76%. All right, we're getting closer. Let's work our way to n. Set your fraction up this time. Again, 1250s on the bottom. How many times was n drawn? N was drawn 238. You divide 238 divided by 1250. This time you get 19.04%. And guys, this is why I said don't round. Notice how close B and N are. They're only 0.72 away from one another. It's not even a full percentage. Don't round these. All right, let's finish this out. We got two letters left. So we got G and we have O. All right, for G, 241. So we're going to divide 241 divided by 1,250. When I divide, you get 19.28%. And last but not least, I've also got O. So then O is going to be 252 over 1,250. And when we divide here, we end up with 20.16%. And it wants to know which of these is closest to this one. We did all that work because we want to see which experimental probability is closest to theoretical probability. And just by looking at these, you can tell that O is actually going to be the closest. O is 0.16 away, whereas B, close second, is going to be 0.24 away. So O would have been the closest in experimental probability to letter B. So there you go. There's your answer to number 4. All right, guys, let's move on to our last problem for today, and then we'll finish this out tomorrow. So number 5. If you're at home, hopefully you're watching this video. If you have any questions, let me know. Also, guys, go through your test prep and correct it. I cannot stress enough how similar this test prep is going to be to your test. So please, please, please make sure that you are paying attention and you're asking any questions that you might have. Number 5, last one. To play a game, a number cube with sides numbered 1 through 6 is rolled and a fair coin is flipped. Complete the table to represent the sample space. Guys, this is, they didn't really ask you to solve here. They just asked you to complete the table. So this is going to be a nice question to end on. And they've even set up your table for you. Heads, tails. You've got numbers 1, 2, 3, 4, 5, 6. They've set it up for you. Don't make it harder than it needs to be. In this first box, I'm just taking my row, matching it up with my columns. So in my first row, I'm going to have H1. So I move over, I'm going to have H2, H3, H4, H5, and H6. Bottom row, I'm going to have T1, T2, T3, T4, T5, and T6. And there you go. The table's completed. Now, I can look at this and tell how many different outcomes there are. There are 12 different outcomes here that I could have. I could roll heads with the number 1, could roll tails with the number 4, could roll heads with the number 5. If I could count up all these different options, and I could find out, hey, there are 12 outcomes here. Guys, I hope you enjoyed the video. I hope you did really well in your test prep worksheet. Again, hopefully you're sitting down correcting it and you are going through it, making sure that you got 100% on it. If you have any questions, let me know. We'll pick back up where we were tomorrow, and then on Thursday, expect a test over this chapter. Again, test is going to look very similar to this test prep, all right? Guys, it's been a pleasure. Have a good day.